So we've got circles, circle and a line. First of all, we'll start off by writing down what is the general equation of a circle. The general equation of a circle, x minus a all squared plus y minus b all squared is equal to r squared. The general equation of a line, y is equal to mx plus c. Just like in the line, we need to know what each of these letters represent. So in a line, y, x represent coordinates of points on the line. Coordinates of points. Not any point, points on the line. Very important to understand that they represent coordinates of points on the line. Likewise, x and y here in the equation of a circle also represent the same thing. Coordinates of points on the circle. So they are our variables. They will vary. X and y vary for different points on the circle. If you imagine drawing a circle, you've got an infinite number of coordinates, so you can have an infinite number of x and y values. Likewise, for the straight line, we can have an infinite number of x, y coordinates. So they are varying all the time, the x and y, depending on the point that we're in. So they are our variables. However, the other things that we've got here in the equation is the m, which is a gradient, is a constant. For a particular line, it will be a particular gradient. Gradient is particular to a line. Where it crosses the y-axis is also particular to a line. When I say particular, you can kind of say it's constant for a particular line as well. So gradient is constant for particular or particular to a line. Likewise, the y-intercept is constant or particular for a line. Now the same happens with the circle. We've got a few things here. We've got A and I know there's a minus in front of them, but we take the A and B as the positive, the opposite of the sign A and B here will represent the coordinate of the center of circle. I'll mark that here on this diagram. There's my center, and I'll mark A, B as the coordinate of the center of the circle. And again, this will be particular or constant for a circle. For a different circle, it will be a different center point, but it won't vary for that particular circle. It's a constant. So coordinate of the center of the circle, which is constant or particular to that circle, or for that circle, particular for that circle. And then we've got R here, which is the radius. And this also, as you can imagine, because once we know a circle, it'll have a particular size, and that radius will fix that size. So then the circle won't get large or smaller, it will remain that same size. So the radius R is constant or particular for that circle. So you can see the similarities between the equation of a line and circle. First of all, we've got the x and y, which are our variables, and then we've got these constants. For a circle, it's a and b, which is the center, and r, which is the radius. For a line, it was gradient and y-intercept. So how did we find the equation of a line? Well, we needed to find the gradient first. We found the gradient first. and then we substitute a, because once you've got a gradient, you would have you've got gradient, and if you can substitute an x and a y, then in that equation which involves those 4 unknowns, you would know 3 of them, so you can then find c. So we substitute a coordinate on the line to c. So we find m and then we find c. Done. You got the equation of a line. Now we can do the same thing for a circle. What do we do first? Well, you can find center of the circle, AB. And once you found that, just like the line, you would then have all the things you would know, A, B, and if you have a coordinate which is on the circle, X and Y, you can substitute that, and the only unknown that you'll be left with is R. So then you'll be able to find out what that radius R is. Okay, if R is not, here's a circle, as you can see, and the center of this circle is at the origin. Okay, we've got a point, a general point on the circle marked with X and Y. We don't know what X and Y are. Any points on the circle will have coordinates X and Y. So those X and Y represent the X and Y in our equation. And so then what we've got here is, as you can see here, the length here of a triangle, the X distance here and the Y distance here, and then this here is the radius of the circle, but it's also the hypotenuse of this triangle. So if we then go and apply Pythagoras to this right angle triangle, what do we get? We get x squared plus y squared equals r squared. Now this is the equation, general equation of a circle whose center is at the origin. So it's a very specific one where the center is at the origin. i.e., if we had this, if a is 0 and b is 0 because it's at the origin, it simplifies to x squared plus y squared equals r squared. So that's one where the center is at the origin. But what if the center is not at the origin? How would we find the equation of a circle? Let's take a look at one of those examples here. So if the center is not on the origin, we'll label the center being AB. So you can see where AB come from. Remember, in our general equation of a circle, A and B denoted the center. So here we're just saying let A and B be the center of the circle. So we can do a similar thing here. We've got our radius drawn, and then we've got a right angle triangle by going horizontally. Because if you remember what I said on the previous chapter when we were finding areas of triangles within the y-x plane, it's easier to kind of look at horizontal and vertical distances, because those things we can find very easily by looking at the difference in the x coordinates and difference in y coordinates. So I could have drawn this right angle triangle differently, but it makes sense to draw it horizontally and vertically for that particular reason. So how can I then find, well, what can I apply to this? Well, it's a right angle triangle. Find these distances first. So let me find that distance. What's this distance here, this horizontal distance that I've marked here? Any idea how I might find this? Look at my coordinates. I've got 2 coordinates. So I should be able to find out what this distance is. Any takers on what that distance is? X minus a. Thank you. You can see here, there's x. Higher value, take away a, gives me that distance. Likewise, we can find this vertical distance by looking at the difference in the y coordinates. So if I look at my y coordinates here, I'm done. X minus a and y minus b. Now we've got the sides of this triangle. So applying Pythagoras then gets us x minus a all squared, so this side squared, plus y minus b all squared is equal to r squared. So here we have the general equation of a circle. So the first line, it says there are 2 points. So it doesn't even ask for a circle. So the first part, you should be able to just plot A, label it 5 minus 1, plot B, label it 13, 11. Why have I drawn one down here, one up there? Well, if you look at relative to each other, 5 x coordinate is less, b x coordinate 13 is higher, so b is going to be to the right of it. The y coordinate of a is -1 and the y coordinate of b is 11, so 11 is higher. So I've drawn them relative to each other in a correct position, but I didn't go and draw an xy plane, which is not necessary. You can if you want to, but it's not necessary. Okay, so I've got my points relative to each other in the correct position. The first part is asking you to find the midpoint. The first part is finding the midpoint. That should have been relatively straightforward. 13 add 5, which is 18, divided by 2, 9. 11 add -1, which is 10, divided by 2. 9, 5 is that coordinate of the center. Part B, so again, we're doing line by line. Someone mentioned line by line, so here we're doing it. AB is the diameter. So if this is the diameter, then 9, 5 must be the what? It must be the center of the circle. Because remember, a diameter goes through the center of a circle. And if the midpoint of that diameter we know, then that will be the center of the circle. So now I've added more to my diagram. Now it says find the equation of C. So again, we're doing line by line maths. We added to the diagram from the previous line. We're going to start by writing down the general equation of a circle. Just like we write down y equals mx plus c, this will be your first step. X minus a squared plus y minus b squared is equal to r squared. And just like we did with y equals mx plus c, we found the gradient first. Here we find the center. Now we already got the center, so we're going to substitute the center in. So what do we have? X minus, and then what is a? 9 all squared plus y minus, what is the y coordinate of the center? It's 5. Put that in. Is equal to r squared. Now, we still need to find out what radius is, but in order to find the radius, we need to know a coordinate on the circle. If you remember, that's what I said here. We need to substitute a coordinate that is on the circle in order to find r. Just like we find c by substituting a coordinate on the line in y equals mx plus c. So do we know a coordinate on the line? Can I substitute 9, 5 instead of x and y? Can I yes, the b, which is on the circle, and a is on the circle, we can substitute either of those instead of x and y. Remember what x and y represent. We wrote that down in our original general equation. X and y represent coordinates of points on the circle, and I marked those points there. Coordinates of points on the circle. So we can only substitute those in. So I can only substitute either A or B. You need to choose which one. It doesn't really matter. I'll go and use 5 and -1. So instead of x, 5 minus 9 all squared plus, instead of y, I'm going to substitute -1 minus the 5 all squared is equal to r squared. So there we've got 5 minus 9, which is -4. Just going to go here. -4 all squared plus -6 all squared is equal to r squared. So if I tidy this up here, I've got 16 plus 36. Remember, you're squaring a negative number, you'll get positive here, is equal to r squared. So 36 plus 16 is 52, which is equal to r squared. Yes, r is the root of that. You can find that there. Okay, now we go back to our general equation. Just like we do with y equals mx plus c, we go and rewrite everything. We x there because x and y are variables, and we need to write down the specific particulars, i.e. the center point and the radius on that. So what is it going to be? It's going to be x minus, what's the center point? 9 all squared plus y minus 5 all squared is equal to r squared. What is r squared? Well, you could write root 52 squared, or you can just go and substitute what r squared is. R squared here, as you can see, is 52. So you can write it like this, 52. Or if you wrote it as this r, then it would be root 52 all squared. This is a quadratic, and this is a straight line. When we solved this earlier, I think it was in chapter 2, 3, I can't remember, 3, yeah. Quadratic curve and a line, and we looked at solving them. When we substituted the line into the curve, what did we end up with for this? A quadratic also, right? We also looked at solving just solutions. When we had that, that was just a general quadratic. We had cases where you could have two solutions. We had cases where you could have no solutions, i.e. it doesn't cross the x-axis, or cases where you just get one solution. With this quadratic and line, we had cases where you could have the line just passing through, missing it, so there's no intersections. On this one, there were two intersections. Or we had the case where we had the line just touching the quadratic, resulting in only one intersection. Now, can we get those similar kind of cases with a circle? Since we get a quadratic, if we look at the circle, the line could pass through the circle. The line could touch the circle at one point, giving one intersection. Or it could miss the circle completely, giving no solutions. So in all of these cases, when we substituted the line into the quadratic or the line into the circle, we end up with a quadratic equation. And we know something about quadratic equations, the ax squared plus bx plus c. We know something that enables us to determine whether it will have two intersections or whether it will have one intersection or none. Anyone know what that is? What can we use to determine whether it will have two intersections? Okay, well done. Who said that? Abhishek.
And Mahdi and Sakib.
Mahdi, Sakib. Anyone? Are we clocking on here? If you have kind of figured out what those guys are saying, just put a thumbs up next to theirs once you've made that connection. Put a thumbs up next to their comment. We've got some thumbs up?
Yeah, we've got 3, 4, 5,
okay.
9, 10, 11.
Right, so good. So what do we know? Well, let's look at this case here then. This case here where we had the quadratic, this one here, not touching it. We knew that the b squared minus 4ac would have to be less than 0, no solution. This one is b squared minus 4ac equals 0. This one, two solutions, b squared minus 4ac is greater than 0. No solutions, b squared minus 4ac is less than 0. One solution, b squared minus 4ac equals 0. All result in a quadratic equation being formed, so surely there is a discriminant to be found. All quadratic equations, we can work out a discriminant. So this one as well, when we substitute the line into a circle, we actually form a quadratic equation. So therefore, the discriminant of that quadratic equation will tell us how many intersections it has. So b squared minus 4ac is greater than 0, two solutions, two intersections. B squared minus 4ac equals to 0, one intersection. And b squared minus 4ac is less than 0 in this case because there's no intersection. Are we happy with that? So we've made some links with other stuff that we've done earlier on in the chapters with quadratics and lines and just solutions of a quadratic. Essentially, anything that forms a quadratic equation will have a discriminant, which will tell us if we were to solve that quadratic equation, how many solutions it will have.